So first I want to apologize for my bad English, so if you don't understand me, don't hesitate to ask questions about this, especially when I speak fast. My English is not so good. Second, as I have the honor to be the last speaker, I will not make a synthesis, but I will try to put together different pieces of the puzzle we discuss. Of course, the first one is non-locality. I think all the physicists who have mentioned non-locality. So, of course, it's absolutely crucial. I just put a picture of the Alaspe experiment. But one thing we must have in mind before speaking about the importance of non-locality, that there are two ways of considering this phenomenon. You can speak about an influence which is outside matter and energy, because otherwise it could not travel faster than the speed of light, and which goes from one particle to the other. In which case we speak about non-locality because it violated the locality principle as conceived by Einstein. And that was the original idea of John Bell. I'm going to speak about him in this famous book, Speakable and Unspeakable in Quantum Mechanics. But I think this vision now is more or less ruled out. We will discuss by the experiment like the before by Nicolas and Antoine. So now the vision of the non-locality is mostly what we call in French non-separability. That means the two particles form only the same object. It's only one object. Even if they are measured in instruments thousands of miles apart, in this case, there is not the possibility to cut the system in two parts. The system cannot be separated, of course, before the measurement. So there is this idea of a global system. The two particles form one global system, and that's, of course, completely amazing for our classical vision of what is an object in space and time. So the first point, the first crucial point I think this meeting shows very clearly is that reality is not in space and time. And as Bernard d'Espagna, the famous French philosopher and quantum physicist, state, in any case, the two visions of non-locality or non-separability, the conclusion is the same. The two descriptions are equivalent because in either case, a violation of Einsteinian separability necessitates an instantaneous interaction at a distance, either between two distinct systems or within a single and same system spread out over space. And of course, here you cannot have any classical vision of such a system. So, in any case, with non-locality, non-separability, no matter about, we are invited to radically revise our belief about the very foundation of reality. And that, I think, is one of the most solid conclusions we can have from this meeting. As Nicolas Gisin put it in his word, physics as a word for the cause of these non-local correlations, entanglement, but physics offers no story in space and time to explain or describe how these correlations happen. And somehow non-local correlations emerge from outside space-time. So that's, as I mentioned, conclusion number one. Okay, I think most of us are going to agree on this. Even if we accept exotic models like the many-world or the De Broglie, Bohm, Bell model, BBB, it's De Broglie, Bohm, David Bohm, John Bell. Even in these things, you cannot escape non-locality. I will not develop, but that's, I think, something we agree on also, even if the higher Church of Hilbert mentioned by Gilles. By the way, you have a tribute to Gilles here. You have a Schrödinger cat who is in a superposition state, is dead and alive at the same time, so you have a macroscopic object in superposition. That's just a tribute to Gilles, okay? So, now the next question is, what is ultimate reality? We say, okay, it's not in space and time. But, by definition, that's a very important philosophical point, ultimate reality cannot depend for some of its characteristics on the way in which it is being observed. Of course, if it depends on the way it is being observed, it is not ultimate reality. Okay? Yet, quantum physics show us, except maybe, that's, we must be cautious, in the de Broglie-Bohm-Bell model, that the reality in which we live, embedded in time, space, energy, and matter, is like a rainbow. Yes, like a rainbow. Why? Look at a rainbow. If you move, the rainbow moves, okay? So you are not, it's not possible to speak about the position and the speed of this rainbow. That would be absurd to speak about this, okay? Because it depends on your position and your speed. And the great discovery of quantum physics, of the new vision of the world, the great discovery, the amazing discovery, is that all the elementary particles, the characteristic of all the particles inside this, or this, okay? All the elementary particles, the characteristic of these elementary particles are like the rainbow. They depend on the way we observe them. We must be cautious. So we can say ultimate reality is non-material, yes, if. That's the cautious point. If models like the BBB are falsified, it's why it's an important topic we'll discuss after in the conclusion for experiment to do. So is ultimate reality non-local? Yes. Is ultimate reality non-material? Yes, probably, because material objects are like the rainbow. And I quote the Spaniard another time. One of the teachings of modern science of the so-called matter is the following. The thing, is there is one, which remains preserved, is not concrete but abstract. It is not something which is close to the sense, but which, on the contrary, is a pure mathematically abstract number, such as theoretical physics has revealed to us. In other terms, compared to our sense and the concepts that are familiar to us, reality is undeniably distant. In order to do justice to this very important discovery, when we speak about it, I think that it's crucial to know that the word matter is the wrong one, and that the more appropriate word being, l'être in French language, should be reintroduced. Okay? So that's, I think, the conclusion of my first part. And that's a very, of course, we must be cautious. There is the if, but we can say ultimate reality is non-material, is first non-local, and second probably non-material. This opened a lot of doors. And here is a tribute to Antoine and his famous article about classical demon and quantum angel. So I bring an angel and demon. Now he speaks about John Bell's. So I will be obliged to put the John Bell's picture in. It will be less sexy than my angel, okay? But what Antoine is saying on the basis of what I have synthesized just before, what Antoine is saying in this famous paper is this quite amazing thing. He says, this means that the quantum correlation have roots outside space-time, we agree, and in this sense originate from a free and intelligent agent. Strong claim. One is led to accept the two freedoms, the freedom of the experimenter and the freedom of nature, and to see quantum randomness as a particular expression of free will. And he say, actually, I think that the experiment with moving device, like the before he have done with Nicola, I described before in the article, are stronger proof of the free will theorem, who was presented by the free will theorem from Conway and Cauchy. If we assume to be someone rather than nothing, if I assume to share intellect and free will, if I claim in particular that the author of this article is not exclusively the Big Bang, it's not determined from the Big Bang, you want to say, I have to accept that there is some intellect behind the quantum phenomena, rather than assuming that there is nothing. Okay, great, but of course sometimes I challenge, I love this, it's fantastic, but sometimes I challenge Antoine, and I say to him, I think you have not demonstrate this, you have not proved this really, but it's possible, and that's great. It's possible because of the opening given to us by quantum physics. So, how we can go further? That's my second part of my talk. And of course, to go further, we have to link this with the second topic here, it is consciousness, okay? But before we have a problem. The problem is this, what I call the Gell-Mann effect. It's a joke, of course. But the Gell-Mann effect, what is it? Gell-Mann is an absolutely top-level ranking physicist, as you know. But in his book, The Quark and the Jaguar, I cannot have many time to develop, but he say, oh, people say a lot of crazy and wrong thing about quantum mechanics. I will explain you. It's very simple. It's like my friend John Bell have explained in this famous book, Speakable and Unspeakable in Quantum Mechanics. You have Mr. Bertelmann is a mathematician. He wear always a pink and a red socks. So if you see him arriving in the room and you see a red socks, you know that the other sock is green, okay? Because you know his behavior, and you know that he have always two different socks, and you observe the first socks, and he say, so all the people are speaking about crazy things concerning quantum mechanics, but in fact there's nothing more mysterious than what I just described. There's two socks from the origin, one green, one red. When you observe the first one, you know the other is the opposite color. Or in fact, the only thing which is right in what he's saying is the no signaling. He say no signal pass from one photon to the other. No action take place from a distance. Yes, because the two photons are one single object outside space and time. But this, you can never guess this when you read the Gell-Mann paper on this. In fact, he said the wrong allegation according to which the measurement of one photon immediately affects the other leads to all kinds of unfortunate conclusions. And this is absolutely wrong. You can trust me. I have presented this to Bernard Espagna and Roger Penrose, two great specialists. And in the meeting organized by Andrew in Oxford 3 weeks ago, Penrose, I have not seen him for 5 years, Penrose just, he ran to me and said, oh, Jean, you was right. Gell-Mann is not able to understand what is entanglement. And that's, for people who know who is Gell-Mann, it's simply impossible to believe. And this is the Gell-Mann effect. That means Gell-Mann have, of course, all the scientific level needed to understand the problem. You have all the level, you have 10 times the level to understand the article from John Bell, okay? He's honest. I'm sure he's an honest person. He read the article, and he said the article is saying exactly the opposite of what the article is saying and what the experiment is demonstrate. Okay? That's the Gell-Mann effect. And the funny thing is that the Gell-Mann effect you can find in many different places. I have spoken with Nicola yesterday at dinner, and he said that the Gell-Mann effect is much more propagated in the community than I imagined before. So why we need the Gell-Mann effect? We need the Gell-Mann effect in mind for the second topic of my talk. The second topic is the brain like an iPod? In an iPod, you have the music inside, okay? So no problem. The music is in the iPod, and you just hear the music, which came from the iPod. But what about the radio? Imagine some extraterrestrial who look at an iPod and understand very easily how it's working. Now they look at the radio, and of course, they will say, oh, it's very mysterious, the radio. We don't know exactly where is the storage of the music, but because we know about the iPod, we know the music is somewhere in the radio storage, and we can prove this because if we modify a component of the radio, we modify the music. So there's no problem. In fact, we know that the music came from outside. It is not in the radio. So the big question is the brain an iPod or a radio? Today, 99% or 95 or 99% of the neuroscientists will say it's an iPod. There's no question about it. Just don't speak about another possibility. And me, I say, why? If you have in mind what we just demonstrated in quantum physics, the possibility is open for the brain to be a radio, okay? It's here, there's many, in my paper, there's many arguments to show how it's possible for the brain to be a radio, but I want to return on this famous experiment that Alfred Meillet also discussed about Benjamin Libet, where you have this black spot and the people press a button when he's free to press the button. It's not a go signal. He say, I decide to press the button when the dot was on 11 o'clock. Okay. So that's the thing. That's the key problem. This potential, it's what you call readiness potential, RP, and it begins sometimes 1 second, sometimes half of a second in many articles. It's not important, but it begins before the moment the people say, I decide to press the button, and the moment is here. So many people are saying, okay, look, there's no free will, because when I decide to push the button, when I believe I decide to push the button 0.2 seconds before the action, my brain begins to move 0.5 or 0.8 seconds before, okay? So there's no free will. But that's another Gell-Mann effect. That's just a Gell-Mann effect. Because in fact, Libet experiments say exactly the opposite. Libet say that you have some veto. Of course, I agree with Alfred that the veto experiment is not perfect, so we have to improve it absolutely. So we have the veto experiment where the people have this, we record the same potential in the brain, but here the people say, oh, I have veto my movement, I have not pushed the button. So in fact, we are free. We are free to push or to not push the button, but the process is unconsciously created. Why so? Before to conclude, why I don't believe in the critics of Libet experiment. So it's a little more technical, but first you have to explain why there is this readiness potential I just show you. If you say, oh, that is just a preparation of the movement, but in fact it's not, the decision is not taken here, the decision is taken here. But it's exactly what Libet is saying. Libet is saying, yes, we are free to allow the movement to go to the end or to stop it. So the real decision is here. So it's what Libet is saying. So it's not a criticism against Libet if you go this way. After this, there are some readiness potential. There are some patients who move like this. And these patients have absolutely no readiness potential, and they cannot veto the movement. It's a disease. When you train them to veto the movement, the readiness potential appears. So it's linked with readiness potential and veto. Also, the readiness potential lateralizes before the decision time, and no lateralization when there is a go signal, when you are forced to react. And the other thing is that it's clear that the majority of the movements are arbitrary. For example, our president may make this movement. Now you are aware about the fact you are doing this movement, but you can have done this movement. It's an arbitrary movement, okay? So it's not really you decide to do this. It's your brain. But you can take the control. You can decide, no, I will not move, okay? That's really you. So that's, I think, it's our experience. Also, we have the veto of Libet. I will smash his face. I hate this man. Oops. No, I veto. I veto when? 0.2 seconds before the act. We have all experienced this when we was young and we was fighting with our comrade in the, I veto, okay? So I don't want to develop more, but just to mention that some critics of Libet also, not all, but have some ideological presupposition. So to conclude, three forms of conclusion. Conclusion in 2 minutes. No, don't worry. First, on the basis of our present knowledge, it seems reasonable to propose an hypothesis according to which entanglement and consciousness are two manifestations or characteristics of ultimate reality, which are not embedded in space-time, matter, and energy. The existence of free will be a logical consequence of such a situation, an action of consciousness on the brain process, perhaps, like in Libet experiment, but of course a point we have to discuss. But how to test this? It's nice to say something like this. It's nice to say, okay, consciousness came from another level of reality, blah, 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 blah. But how to test this? We have a lot of top experimenters in the room here, so we have to make testing. So just practical experiment to finish. A real unprovoked veto experiment is very important to do. Also, I propose, but there are some ethical issues on this experiment, to do the Libet experiment on free will by associating with the Milgram experiment. Because if you push the button and you really believe you are going to kill someone, that is the Milgram experiment. If you push the button and you believe you are going to kill someone, I predict the readiness potential will be quite different in the brain, okay? but ethical issue, okay. So perhaps we can improve in a way there's less ethical issue. First, third point, Libet in his book, I really advise you to read Mind Time. This book from Ben Libet is for me the best book on the topic of mind. So Libet proposed amazing hypothesis of a conscious mental field. Personally, I don't believe in this hypothesis, but as I said before, we have to test last thing we don't believe in. We must not have pensée unique. So I think Libet gives a very, very detailed protocol of how we can test the hypothesis of a conscious mental field. And the last point is experiment or near-death experience also seem to be important to conduct. And theoretical research are also possible in quantum physics. Very important to falsify the BBB model for the reason I have explained. Perhaps it's still falsified by the before. We have the point we have to discuss with Nicolas and Antoine, but if not, we must falsify this model. We must study more model of interaction between quantum physics and neuroscience, very important. We can approach new approaches of entanglement. Gisin proposed a very stimulating idea using human subjects as detector. Quite amazing. You have to ask Nicolas. And of course, working on the possible links between Libet's and Suarez model. It's the connection between the two parts, okay? Suarez model will explain why it is necessary that a large amount of our everyday gestures are unconscious, as it is postulated by Libet. It is the price for Antoine to pay in order to do conscious and voluntary gesture to be possible. So now it's really finished. So my last slide is this. All we discuss here have social implication. It's not only nice things for philosophy or researcher. Here you have some sentence from two people who are agnostic and quite neutral in France, Ortoli and Farabod, in the famous book, The Quantique des Quantiques. There's a play on word in the title. And they say something amazing. They say quantum physics in the future will have more impact in history than Republican, Marxist, Islamic, and other revolution. All this revolution may one day appear insignificant compared to the quantum revolution. Our socio-political organization, our way of thought, have been or will be disrupted more probably than by any other event. Why? He says our civilization basic philosophy is still mechanical materialism. But simply the idea take time to be pulled down, and specialists only specialists are impressed by their failure. It took years for Galileo's hypothesis about the Earth orbit to be accepted. How much time is needed to shake our current belief? And the point is this: we are in an amazing situation, exactly like four centuries ago. There was a small number of people around Galileo. They know there was another vision of the world. And this vision of the world will transform all the Western society, all the civilization, bit by bit. And we're exactly in the same situation. But the nice thing today is that it's go toward not a mechanical materialism, but something which is more open, not proof, but no more open to spirituality. So it's really our duty to diffuse this vision, to reinforce this vision, to study this vision, because I believe it's the only way to really change and act to change our civilization is to change on the worldview we have about the man, the universe, and life. Thank you.
Right.